Okay. So now, let's explore the world of digital twins with our next speaker, Avirup Basu, founder at Spectro Aviation. He is one of the inventors at Swittons and a GDG organizer of GDG Silguri and an Intel Software Innovator. He is also certified Azure IoT developer and Intel One AI API instructor. Please welcome Avirup on the stage.
Hi guys. So yeah, energy there, or all energy gone after lunch? So how is the Josh? Increase the volume, please. How is the Josh? First of all, no sir. My name is Avirup. Okay. So anyways, so I'm Avirup. Thanks for a lovely introduction. So today's topic is on digital twins, but before we go into that, let's break it down into multiple parts and then get started. Anyways, I am working at P360 as a technical IoT lead. Other than that, I have my own startup on drones, which I have named as Spectro Aviation. It will launch probably in the upcoming couple of weeks or months. Let's see if we can launch it soon enough. Other than that, I have flown all over from Siliguri. Anyone knows where Siliguri is? Sorry? Okay, so yeah, so it's in West Bengal, near a place called Darjeeling. So from there I've flown over here yesterday to meet all of you. So let's see the energy of the crowd today. And yeah, so the topic of today's session is digital twins. And what exactly is digital twins? What is digital twins? All those blah blah blah, leave all that apart. What is IoT first? But by the way, anyone knows like digital twins is a concept of IoT that everyone knows, right? Fine. And that part is clear. Okay, before getting into the topic, how many students are here? Please raise your hands. Okay. How many are interested in application development? Okay. And how many interested into cloud? Pretty much 50-50. Okay. How many interested in IoT? Okay. Okay, I got a good crowd. Thanks to the organizers for that. Anyways, so yes, digital twins is all about IoT, and IoT is all about devices, right? IoT is all about devices, all about Arduino, Raspberry Pi, watches. Completely wrong. IoT is all about software. It's like around 70% is software, 30% is hardware. So if somebody comes to say, I want to get started with IoT, ठीक है, घर जाओ, Amazon खोलो, Arduino order करो. कभी मत करना. That's never gonna work out. If somebody comes and says, like, yes, you need to invest thousands of rupees, probably 5 to 6,000 to get a Raspberry Pi. Okay, get some display, get some sensors, buy a touch screen, buy hundreds of stuffs, and then only you can get started IoT. That's never gonna work out. The only way how you can get started IoT is, firstly, if you understand how things work, and then whatever solution you have, whatever problem statement you have, you can literally solve each and everything just by software. Like, I come from a hardware background. I am a pass out in EC, Electronics and Communication. Say, any EC or electrical grads out here? Okay, all CSC folks, right? Perfect, I like that. Cool. Anyway, I come from a hardware background, but still, IoT is a bit of hardware and a lot of software, and a humongous amount of cloud. So that's how IoT is filled in. Anyways, so digital twins, we are going to explore today's topic about digital twins. It's a buzzword in the industry, and a lot of things have been happening with digital twins in the past couple of years, I would say, especially during the lockdown time. So what exactly is digital? Anyone have any idea about it? Yes, sir, please. Hmm.
invest money, so that what is going to happen if it fails, then your whole money is going to loss.
Right.
So that so we make a similar machine in a software in the computer with all the real time data, that is same amount of weight, same conveyor belts and everything, and we stimulate it in that. So हमें पता चलेगा कि वो सही में रन कर रहा है या नहीं. एंड सेकेंड यूज इज कि अगर मेरी मशीन कोई और स्टेट में है, मतलब मेरा फैक्ट्री कोई और स्टेट में है, और मेरे को उसका रियल टाइम डेटा मेरे को चाहिए कि अभी क्या हो रहा है, उसका रोबोटिक आर्म कहाँ मूव कर क्या भी है, तो वो मुझे डिजिटल ट्विन से मिल सकता है.
May I know your name, please?
स्मिथ सोनार.
Sorry?
स्मिथ सोनार.
Okay, a huge round of applause for this guy. You should come over there and stage check the session, sir. You have given probably the most accurate description of the entire thing that is possible.
Actually, I have been working on this. So.
Okay, that explains it. So good job, man. Yeah, like I was not expecting this kind of matured answer for digital twins. That's a surprise for me as well. Anyways, like वो तो बोल ही दिया, अब क्या बोलूँ मैं. Organizers कुछ goodies है तो दे देना उसको, ठीक है. Anyways, so again, he has already said like digital twins is nothing but according to the textbook definition, although there are no textbook definition of digital twins, but according to textbook definition, it's a virtual representation of a physical object. Now here I have not mentioned about like there are multiple types of digital twins. There are multiple ways how you can create a digital twin, but essentially you have a device. You don't know how the device works. You don't know how the process works. You have no clue how this will act in the real world. So if you even make a car for now, let's leave that car apart. Let's bring in the concept of, okay, any idea who first, like which was the first organization to implement digital twins in real life? You don't answer. I know you'll know. Any idea like which is the first organization in the entire, I mean, as of now in documented history, who used this concept at the very beginning? And that was most widely used. So that is NASA. So NASA used this first technology in a particular rover which they sent it to Mars. The rover's name was Pathfinder. So anyone have seen the movie Martian? Yes. In the Martian, they have shown Pathfinder robot somewhere in the Martian environment, and at the same time, they were able to exactly simulate the same thing on Earth, like how that will react. So that is the first example of real-world application of digital twins. That is what it is in real life, and that is how it can be used. Now, like all these digital twins and everything is fine, but what is the use of it? Like, why do we even need it? Aside from judging how the system will work, aside from the fact, like how it may function, what is the exact need for it? So it's about like completely break it down into 4 different parts. Decision making, you want to understand how the system will function, how the device will function. The second part is how to design that system. So even if you want to create a digital twin of this particular room, because this room is also a system, right? You have projectors, you have air conditioners, you have ventilation, you even have curtains which will provide the amount of light, like it is controlling the amount of light that is coming inside this room. So all these are like a parts of a system. Some things are input, some things are output. We are sitting here in this room. So obviously we are also creating some form of heat energy, right? Because multiple people are in this room. Then like if we amount more light to enter, so everything kind of affects the system in some way or the other. So if you want to create a digital twin of this particular room, then why do you need it? Like I want to know, like if the number of participants are like 100 plus or 150 plus, what might be the setting of this? I mean, for now it is not much of a concern. It's just you just have to open a jumper and wear a jumper. That's it. If it gets heat up or not. But if it's an environment where I need to really control the temperature, like for example, if it's a medical lab, if you are a research scientist working in some laboratory, you want to maintain the strict conditions like humidity level, the temperature level, the dust level, like how chips are manufactured, where all the experimentation happens, all those clean rooms, you need to maintain each and everything, each and every parameter. So that is where all these digital twins comes into Like a lot of focus is there. So I have prepared a couple of things related to the power industry, like how digital twins are being used in the power industry. And at the end of the session, what I'm going to show you is how exactly you can build one digital twin, like how you can implement it. And I think that's the interesting part. I can already see him smiling for that. Okay, so these are some, I won't say boring, but probably you can just click a picture of whatever you want. I will just share it. So these are just types of twins. As it was said earlier, we have asset like physical objects, digital presence. We have processes like our entire process. For example, manufacturing of a car, manufacturing of a device. Like you know the term industrial automation, right? And Gujarat is a state of industries. Like there are probably more than hundreds of factories based out of Gujarat which runs these assembly lines and conveyor belts. So all these are processes. Digitization of this process to see how it works. That is called process tree. Then there are components, like at a very grassroots level, how these individual components function. That is another type of digital twin. And last is the entire system, how this entire system is functioning as a whole. That's pretty much of it. Now with respect to the power plants, let's get started about a quick interactive session about like try to break down the power plant. What kind of components happen in a power plant? Start from the first thing. So what kind of things are there in the power plant that can be digitized? Let's get started, please, sir. Anyone? Volume up. Okay. Monitoring of power generation and yes, generator. Okay. Okay, let me just simplify things a bit. I am referring to thermal power plant. Now please sir. Sorry? Okay, controlling pressure, okay, yes. Right. Huh. Right. Yes, you're explaining like pretty much the entire process. What I'm interested to know, like what are the parameters that you're interested to learn? I mean, which will be a topic of interest for me to optimize the process? Yes. Right, the efficiency, basically the amount of power that is being generated from a particular mass of coal or some amount of water in case of hydraulic. The second thing will be monitoring all those parameters, that is a temperature, pressure, then humidity level of those boilers. Then the third thing will be the boiler efficiency, like how much heat is being generated by the boiler versus the amount of power that is being output from each of these power stations. So there are multiple things that are being done. Have you like ever visited an industry to? That's a good. Okay, that's a good music. Thank you, sir. Okay, so have anyone visited any kind of in this industry to see how the control room looks like? Yes. Okay. So have you seen the control room? Okay, that looks like a kind of futuristic, right? Okay. Somebody raise a hand from here in between? Okay, similar. Yes, sir. Sorry? Mic, please.
Ukai power plant.
Okay. So essentially, if you go to a control room of a power plant, you will see lots of screens are there. There are lots of computers doing some processes, right? But any idea what goes in the back end? Because if you consider all this, there's a particular term that we refer to as, is known as SCADA, SCADA. All these are referred to as SCADA systems. So it stands for, like, I myself forgot what is the full form of it. Something like basically data acquisition and control in simple terms. So if you are referring to a SCADA system, it's pretty much like all these systems, all these machines are connected via LAN to your PLC, and the PLC is connected to a computer. And then the computer which is connected to a station kind of monitors all this data. But the problem is that most of the time, there are some engineers, there are some scientists at the location. They're continuously monitoring the data. The SCADA system is helping them out to get the data. But that is it. That is what it is supposed to do. Nothing else. There are scientists, there are engineers on site who monitor those data, perform those calculations, and then take decisions. Now, what digital twins helps us is that particular section of taking decisions by doing some calculations, that was also automated. So you don't have to just rely on getting the data, but once you get the data, what to do with the data to take in intelligent decisions without the human part of it being involved. That is where the actual automation comes to the picture, and that is where the digital twins is mostly used in real life scenarios. Now you can literally simulate, like if this is my input, this is the amount of power being generated, this is the efficiency, then what should be the parameters? If these are a parameter, then what should be my output? So all this forms a correlation factor. So what we call as a mathematical modeling. So once this mathematical modeling is implemented in a digital twin, then it gets much easier to take those business level, analytical level decisions, as in how the system will perform. As I said earlier, like digital twins isn't just automation. Automation is a part of IoT, but digital twins is not about that automation. It's essentially like combining multiple things into a singular entity to automate the entire process and take decisions. Like autonomous decisions capability will be there in case of digital twins. This is kind of like with respect to power plants, the types of digital twins that are possible, very complex terms probably. Some of these like doesn't even really matter. So you can just ignore it, or you can just again click a picture. It's pretty much simplified. Like if you break down a power generation process, multiple things, how each thing falls under simple category of digital twin, that is what it is explained. But the interesting part comes, what happens, like how does it improve the efficiency of the power generation with respect to power plants of a digital twin. Firstly, I mean efficiency is handled because the human part is eliminated. Obviously manual takeover is always there because you don't want another Chernobyl to be happening, right? Then again another TV series will be released. Anyone watch a Chernobyl TV series? Come on, जो लोग नहीं देखा देख लो भाई, बहुत अच्छा है. पता है ना the Chernobyl power plant incident? Okay, fine. At least that is known. Anyways, so as a whole of the power ecosystem, how can we eliminate the human factor? How can we take decisions, intelligent decisions? How can we optimize the entire flow of the process? How can we bring in more controllability, more computer-aided modeling, more mathematical modeling capabilities to increase the efficiency is quite useful in case of digital twins. But if you just go to the internet right now, if you just open your cell phones, go to YouTube and just search digital twins, the first example that you'll get is digital twins is all about visualization, quote unquote. So you have a physical device, you create a 3D model in the web or in Autodesk software, something of that sort, and you just showcase all the sensor data. That is a perception as an user that we have our digital twins. But that's not it. It's the entire process, how we automate to get in the data, to process it, to take in decisions, and that's all you can say that's pretty much what it's all about, digital twins. But all of this that I've been discussing is like pretty much standard textbook definition. How do we implement it? How do we actually build a digital twin of a system? That's where the interesting part arises. So digital twin, as I said, it just isn't simulation, but a modeling using real-time parameters, emphasis on the word real-time. Now, why real-time? Why digital twin is kind of real-time, like based on real-time parameters and not just simulated parameters. Like as I said at the very beginning, like in case of digital twins, we are not interested in simulation. Simulation, like it has been age-old. Like people are doing simulation since decades. But in digital twins, we are not interested in that. In digital twins, what we're interested, that you have a physical system, the real-time data you get. Based on the real-time data, how efficiency can take a decision, that is the actual concept. Again, how do we build it? Now let's get into the topic of building it. Firstly, of building the entire technical architecture of a digital twin, let's break it down again. So if anyone of you have worked on IoT systems, the physical part of the IoT system is referred to as an edge device. How will the edge device communicate to the internet? Any idea? Like if you break down into two parts, device to cloud communication, cloud to device communication. How will the device to cloud communication happen? Let's say you have a cell phone right now. How will the device to cloud communication will happen? Any idea? Yes, sir? So what you mentioned is essentially like an authentication method. Through connection string, you're sending the data to the cloud. But my question is, again, break it down. How will a device send data to the internet? Connection string is just an authentication method. But how that protocol happens? Yes. That's one method. But what is MQTT essentially? I won't say it's a message passing. I'll come back to this a bit later. But like, you know, REST API calls? Like multiple sessions have been happening since morning. Firebase and all those. Like Firebase is again a cloud-based system. Mobile apps are local. You communicate data to the Firebase system through a REST API, mostly either through REST API or through WebSockets, right? Now, if I want to send a message from device to cloud, it's pretty much straightforward. Because I know cloud's IP, I know where to send the data, straightforward. How to do the other way around is the complicated part. Because these devices don't have a fixed IP. How do you send data back to the device from the cloud? How will you locate the device? That's the difficult part. And that's why normal REST API protocols or HTTP protocols or websites don't work in this kind of systems unless until they have a fixed IP. The second part is networking. Like you have thousands of devices. How will each communicate through to each other? The M2M communication. How will the cloud know, like I need to send message to this device and not to any other device? How the device management will happen? The third part is the cloud infrastructure, which Rusha will cover in some time, I guess. The cloud infrastructure part of it. And the fourth point is about the event processing. So if you're dealing with IoT, if you're dealing with digital twins, you need to deal with a lot of real-time data. How do we deal with this event processing real-time is another challenge. And the last is pretty much straightforward, like data storage and real-time decision-making capability. And there are thousands of frameworks that can do it. My point out here is that whatever point I have mentioned in this slide, okay, I might be covering it, right? Okay, whatever pointers that I mentioned over here, these all are existing in any cloud system that they are available. Take GCP for example. Everything is there. Probably IoT will be rolled off. I think 2020 they're going to shut down the IoT services. Then what's the solution to it? Then networking, pretty much everything is available. Take Azure, take AWS, pretty much everything is here. But problem arises when a particular cloud solution does not provide these things natively. Then the challenge comes is of building it from your own code base, deploying it as an infrastructure to a cloud service, and then building a solution. This is what I've been mentioning about C2D and D2C. The most important part of digital twins, like cloud to device communication and device to cloud communication. Cloud to device to cloud is straightforward, but cloud to device is a difficult part. So as I have mentioned about MQTT, does anyone knows what is MQTT? Yes? And that is a full form, but what it is?
It works as an agent to transport what kind of services and client needs. Like there are different types of clients, and there are one server, and from that server or from that provider, the message that agent helps to distribute all the subscription to the client. Like whoever has subscribed.
Got it. Essentially, can you just bring it down to a very simple definition? Like MQTT.
Provider,
Okay.
agent,
Huh.
and the subscriber.
And you are saying something? Thank you, ma'am. And you are saying something, sir? Yeah, it's essentially that is what you call as a pub-sub model. So you have a publisher, you have a subscriber, you have a client, and these clients can communicate to each other using subscriptions. They can communicate to each other using topics, And a publisher can be a subscriber can be a publisher, and blah, blah, blah. All those things. I'm not going to details of how MQTT works, but essentially in MQTT, you have software clients, you have hardware clients. If all those are connected to a same server, then the message exchange happens with the help of topics. That's how you do device to cloud or cloud to device communication. It's in the same messaging broker. So we in MQTT is called as an MQTT broker. Any example of MQTT broker? I think Google PubSub is kind of follows the MQTT structure, but not truly MQTT. It's kind of based on protocol AMQP. Advanced Message Queue. I forgot the full form. It's AMQP, and MQTT as of now natively is not supported that much on any cloud platform natively, but you can definitely build your own. So that was about how do you perform the cloud to device and device to cloud communication. And that is the most important part when it comes to building digital twins or building this IoT infrastructure. Other than this, you have other ways how you can send data to the cloud using REST API, using WebSockets, and others like other methods are there. Device to cloud, you have only message broker based. Nothing else is there, unless and until it is hosted on an IP. The PubSub model, this picture is taken from reference from AWS. So essentially, you have a broker, you have topics, and through topics you can communicate with each other. So the only way devices can know that yes, I have to send a message to this device is through the user of topics. That's probably the best way how you can do it. Now the question arises, and here it's a bit of an architectural kind of a conceptual question. Like if you're dealing with MQTT as a whole, don't you think that there is a flaw in something? Like first of all, these topics are exposed. Anyone can create new topics. There is always a question of security. It's not that much secure. The second thing is, I mean, if you're talking truly MQTT terms, it's not that much secure. The second thing is that the broker is a server. That goes down, everything is done. That's another challenge. And the third challenge will be, like in case of MQTT, a publisher can be a subscriber can be a publisher. So I am publishing messages to a topic. I can also receive messages to a topic. If it is not like logically controlled, sorry for that. If it is not logically controlled, then you might end up getting stuck in an infinite loop where you are only sending and you are also getting those same messages, and then it's very difficult to get a control of it. There are certain disadvantages and advantages. That's why when you're building an IoT solution, especially with respect to digital twins, then you have to combine some other protocols like HTTPS along with MQTT and MQTTS, what you call as an MQTT secured, to do this kind of cloud to device and device to cloud communication. Processing the data, all those things are pretty much straightforward. Like once you can send the data in near real time, not real time, near real time to the cloud using MQTT or any other protocols, then you can have a microservice kind of an architecture in the cloud which will keep on triggering this, like keep on handling this incoming data to process it. The second type is the typical client server model, in which you have a centralized server, you have the broker hosted somewhere, send in data, server is doing everything, and then just passing it forward. The third is a REST API trigger based model where you don't use MQTT at all. You just send the data to the cloud through REST API, and then entire thing gets triggered. And the last one is an event queue based model where essentially you are combining the REST API as well as MQTT to get your stuff done. So all these 4 points that I've mentioned is kind of very much, it's more of a cloud based topic than an IoT based topic, I guess. So what I'm trying to say is that if you're dealing with IoT devices, like personally speaking, everything that I've mentioned over here at some point will be used. So let's say I have a let's say a fault detection system. Like in new iPhones, there is a fault detection system, right? And sometimes false alarms gets triggered. I guess you have seen. I don't know, like if anyone has seen that news in Twitter, like in USA, there were repeated calls to 911 from a particular location that multiple faults are being triggered. Yes. Yes, yes. So what was happening? Like they were having iPhones and they were in the roller coaster. So in the roller coaster they were going up and down, and that down was triggering as a fall detection, and they were triggering calls to 911. That is what it was happening in across multiple devices in the states, is what I have heard. Anyways, so in those kind of systems, it's a one-way communication. You just send the data, you just that a fall has happened, you just send the device location to the server, and the server then handles it. So it's more like a, you can say either it can be again microservice-based architecture or an event queue-based model. Now, if you have a way like a proper industrial automation, where you need to handle multiple messages at once, then it is always safe to follow a queue-based structure, because no messages should be missed, no events should be missed, because every data is extremely useful and it has to be real time. So in those cases, REST API, I guess I might be wrong, but according to my experience, REST API never works in those cases, unless until your entire system is event driven. Like you send the data from the device, totally event based, mostly based on a PubSub model, then only this kind of situation can be handled. This is about the processing part of the data. It's a typical architecture that I provided that we use while creation of digital twins. And I've been speaking about digital twins all this while, but like can anyone, like, probably after whatever you have heard, all those conceptualized terms, can you create a digital twin as of now? Like whatever I have showcased over here, specifically based on this architecture diagram, will you be in a condition to create a digital twin? So whatever I have mentioned is a way how you can get the data and you can write the data to the devices. But at any of the slides I have not mentioned, like this is how you actually create a digital twin. The reason being, digital twin is a process automation. It's or a decision making capability. While the core of the digital twin is how do you get data from a device and how do you write data to the device. It's not anything else. Once you know how to get and write data in the device, then the rest of the parts, taking decisions using ML, creating some amazing visualization using Flutter for web or any other tool that is available. Obviously, I have to speak of Flutter since it's a Google event. So, sorry for that. Yeah, but anyway, so like the application part is the easy part, and there are like lots of ways to do it. But getting the data from a device and writing the data to the device is the difficult part. That is where all these slides that I have showcased today focuses on that particular aspect of the digital twins, as in how to get and how to set the data, nothing else. So as of now, any questions? Perfect. Actually, I have not, I mean, these are all a generalized concept, nothing else. So actually, that's the end of the slide. So I won't stretch it out. And that was a, yes, sir? You have a question?
My question is about
Yes.
the SCADA systems you mentioned earlier. So there was this SCADA system targeted nuclear power plant in Iran a couple of years ago. Its centrifuges were automated, and it is said that America targeted the SCADA systems with a virus named Stuxnet.
Okay.
And that was a very huge event in the history of SCADA systems.
Right.
So do we see any security architecture movements today in India SCADA systems based on that event? Because it was
Yes.
very in news and
Right. And I have heard about this incident. So the thing about SCADA systems is that SCADA is a way about getting the data from a physical device in a local environment. But what multiple power companies and before this incident have done is that they have exposed a SCADA system to the cloud. Like that IP was public IP, and there was a way how you could have logged into that SCADA system using the internet. And there are thousands of hackers who can easily crack that, because SCADA systems are like age-old technology. You literally don't have any kind of security protocol implemented. It's just an IP that is exposed. That's it, nothing else. So any like hacker who has enough of experience and enough of patience can get into those. Unless and until you, so if you have a SCADA system specifically to your solution, that is a manufacturing or a power plant at your site, and if you plan on exposing that SCADA IP to the cloud for its use, then you're extremely wrong. That is not the architecture. The architecture is you have a SCADA system that is running locally, you create a digital model of it in the cloud, and then you synchronize the data in between. Because if you're exposing the local system to the cloud, you're doomed. At some point it will be hacked. But if you create a digital model in the cloud, if you do all the calculations in the cloud and then synchronize the data to the local, then the security is trivial, and that's how most of the systems that are designed today are actually implemented. Another example of this is aircraft engines. Like, it's very difficult to monitor aircraft engines unless and until these are like $1 million stuffs. So something might go wrong, however it is designed way. So before deploying an aircraft engine to an aircraft, and whenever an aircraft is actually flying, you have an extra digital replica at the factory, which monitors each and every parameters, and that's how they keep on increasing the efficiency, keep on increasing the fuel efficiency and other stuffs. So that's one of the real-time use. And I have SCADA, the place where I come from, there's a very famous river called River Tista, and it comes from all the way from Sikkim and joins the river Brahmaputra at Bangladesh. So on the River Tista, we have 3 power plants by NHPC, and all those systems have a SCADA inbuilt. They have a digital twin in the cloud. It has been provided by Toshiba. They have synchronized the data, and the NHPC headquarters are at Siliguri, which is like probably 80 kilometers away, not even near the river. And they're able to control the entire 3 power stations from a single head office using this digital twin concept. I've seen that real life that is actually being implemented. Any other questions about digital twins on IoT? Cool. So that's the end of the session, and I hope you enjoyed it. So I am pretty much active in YouTube. Like, I kind of started it for the past 2-3 months. So there I kind of upload all the videos related to IoT and programming in general. And you can also follow me in LinkedIn, Twitter. I'm not that much active on Twitter, but in LinkedIn I am quite active, and on YouTube. On Instagram is called StarVizer. So that's it. I hope you had a great time, and thanks for being such a lovely audience.